Assalamualaikum and greetings to Mr. Darrell and fellow viewers. I am here to present our group project on developing a database system for Swift Right Go car rental using Microsoft Access. This project focuses on addressing the data management challenges faced by the company and enhancing operational efficiency. Before we begin, allow me to introduce myself and my group members. I am Mas Ayuni Binti Padol.
I am SYAFIQAH Binti RAHMAN.
I am IMRAN bin HUSIN.
And I am AFIKA Binti SHAHRIN. Swift Right Go Car Rental is a professional car rental service that offers dependable and affordable vehicle rental options for personal and corporate use. Our company's foundation is providing the best possible renting experience by maintaining a fleet of well-maintained vehicles and prioritizing customer satisfaction. We offer a wide range of vehicles including compact cars, sedans, SUVs, MPVs, and hatchbacks to meet the diverse needs of individuals and businesses. With the growing demand for rental services, Swift Right Go aims to enhance its operational efficiency and data management practices. However, the company currently struggles to maintain accurate and organized records due to manual processing, which increases the chances of errors and delays. This project introduces a database system using Microsoft Access to centralize and streamline data storage and retrieval. A well-structured database will eliminate redundancies, improve data integrity, and ensure the secure handling of sensitive information. This enables Swift Right Go to provide high-quality services and scale its operations efficiently.
Swift Right Go primary challenge is the lack of a centralized database system. Information is scattered across multiple documents and spreadsheets, leading to redundancy and inconsistencies. For instance, customer detail like name, contact information, rental history, etc. may exist in multiple files. Updating this manually is time-consuming and prone to error, making it difficult to maintain up-to-date records. Another significant issue is inability to track vehicle availability in real time. Without a database, it becomes challenging to know which cars are available, rented, or undergoing maintenance. This can result in double bookings or delays in servicing vehicle, ultimately causing customer dissatisfaction and business losses. Manual data entry further increases the chance of error. Mistake in rental dates, car assignment, or pricing not only confuse customer but also undermine trust issue in the company credibility. This error can lead to financial discrepancies over time. Lastly, there is a risk of pure security in handling customer data. Without encryption or access control, sensitive information like personal identification and payment detail is vulnerable to unauthorized access. This poses a serious risk to the company reputation and compliance with data protection standards. To address this issue, implementing a robust data system is crucial for Swift Right Go to streamline its operation, ensure data consistency, and enhance overall efficiency.
To solve the challenges Swift Right Go car faces, we propose implementing a Microsoft Access database system. This system centralizes customer and rental records, reducing redundancy and enabling faster, more accurate data retrieval. Automation minimizes errors and supports reliable decision-making. The database consists of two main tables: the Customers table for storing clients' details like customer ID, name, license number, contact, city, and preferred car type, and the Rentals table, which records transactions such as rental ID, customer ID, car model, rental dates, fees, and payment method. A one-to-many relationship connects these tables via the customer ID, ensuring data consistency and allowing efficient tracking of multiple rentals for each customer. To retrieve and analyze data, we created queries such as filtering rentals by car type, extracting rentals within specific date ranges, and calculating total fees. These queries simplify analysis and decision-making. For data entry, we developed two user-friendly forms: the customer data entry form and the rental data entry form. These forms include drop-down menus for fields like preferred car type and payment method, ensuring consistency and ease of use. Additionally, a multi-page form integrates both customers and rental data for seamless navigation. Finally, comprehensive reports summarize the data. The customer report details client information, the rental report tracks transaction trends, and a multi-table report links rentals to the customers for better insights and service.
The customer tables and rental tables are the two foundational components of our database system.
These tables are designed to store all the essential information about customer and the rental transaction, ensuring that the data is organized, accurate, and easy to retrieve. I will now explain each table in detail, including their structure, functionality, and how they work together. The customer table serves as the central repository for all the customer information, making it a vital part of the system. This table includes fields such as customer ID, name, license number, contact information, city, and preferred card type. The customer ID acts as the primary key, uniquely identifying each customer in the system. It ensures no duplicate records exist and establishes a critical link with the rental tables. Fields like name and contact information are essential for communication, while license number ensures legal compliance. The city field allows us to analyze customer demographic, and preferred card type help us to cater to individual preference. To standardize data entry and reduce error, the preferred card type field utilizes a drop-down menu with predefined options. For instance, staff can select SUV from the drop-down, avoiding inconsistency like spelling error or formatting issues. The rental tables, on the other hand, is designed to track all the car rental transactions. It includes fields such as rental ID, customer ID, car model, rental start date, rental return date, rental fee, and payment method. The rental ID serves as the primary key, ensuring every transaction is uniquely identifiable. The customer ID acts as the foreign key, linking the rentals table to the customer table. This connection allows the system to associate each rental transaction with its respective customer automatically. Fields like car model and payment method are enhanced with drop-down menus to ensure consistency and efficiency data entry. For example, staff can select online transfer as the payment method from a predefined list, avoiding manual errors. Dates for the rental period, such as the start and return dates, help manage to fit availability, while the rental fee field calculates costs, supporting financial tracking. These two tables are interconnected through a one-to-many relationship established via the customer ID. This means a single customer can have multiple rental transactions, but each rental belongs to only one customer. This relationship ensures data consistency, as the customer details are stored only once in the customer's table and linked to multiple transactions in the rental tables. The integrations of these tables facilitates efficient tracking of customer activities and generates insights such as total revenue from a particular customer or their most frequently rented car model. In the datasheet view, the functionality of this relationship becomes clear. The customer table displays a unique row for each customer, complete with all their details, while the rental tables list every transaction. For example, if Firhan Firzani is recorded in the customer table with customer IDs A01, the rentals table will show all his transactions, such as renting an Avanza from December 9 to June 10 from RM170 paid via online transfer.
Queries play a crucial role in our database system by allowing us to retrieve, filter, and analyze data efficiently. I will explain 5 specific queries we created and demonstrate how they function in datasheet view to provide actionable insights for Swift Right Go. The first query is customers by city or car preference. This query is designed to identify customers who either reside in a particular city or prefer a specific car type. In design view, we set criteria for the city field and the preferred car type field using the OR operator to include either condition. For example, if the city is set to Syrian and the preferred car type is SUV, the query will fetch all customers living in Syrian as well as those who prefer SUVs even if they live elsewhere. When the query is executed, the datasheet view displays a comprehensive list of customers meeting either condition. The second query is frequent renters with high fees. This query focuses on identifying customers who rent vehicles frequently and generate significant revenue. To achieve this, we use the Totals query option in design view. The records are grouped by customer ID and we calculate 2 key metrics: the count of rentals per customer and the total rental fees. In the criteria, we set conditions such as more than one rental, count of rentals more than one, total fees exceeding RM90, and sum of fees more than 90. When the query is run, the datasheet view presents a list of frequent renters who contribute the most to the company's revenue. The third query is rentals by car model and fee. This query retrieves rental transactions for specific car models within a defined fee range. In design view, we set criteria for the car model field such as Asia or Viva and apply a condition to the rental fee field such as fees greater than RM100. For instance, this query will extract all rentals involving Asia or Viva cars where the rental fee exceeds RM100. When executed, the datasheet view displays the filtered list of transactions, showing details like the car model, rental period, and fee.
The fourth query is rental by data range and payment method. This query is tailored to identify rental that occur within a specific data range and were paid using a specific method. In design view, we apply a criterion on the rental start date field using the between function such as between 1st of May 2024 and 1st of July 2024 to capture rental during this period. Additionally, we add a condition for the payment method field to show only online transfer. When execute, the datasheet view display all rental that match this criteria, including detail like the car model, fee, and payment method. The last query is calculated field for total fees. This query simplify the calculation of the total rental fees for each transaction by introducing a calculated field. In design view, we create two calculated files. The first one is rental duration, which calculate the number of days a car was rented using the formula rental return date subtract rental start date. And the second one is the total fee, which multiply the daily rental fee by the rental duration using formula rental fee times rental duration. When the query is executed, the datasheet view display the calculated total fees alongside other transaction details such as the car model and rental period. These features simplify billing for staff and ensure transparency in the fee calculation process.
Now I will explain the forms we created in Microsoft Access for the Swift Whitego database. These forms simplify data entry and improve usability, ensuring accurate and efficient management of customer and rental information. I will describe the features of the forms and the design and demonstrate how to add, update, delete, and navigate records using the buttons we have implemented. The first form is the customer data entry form, which is used to manage customer information. This form allows staff to add new customers, update existing records, delete customer entries, and navigate through all the database to view all customer details. The form includes key fields such as customer ID, name, license number, contact information, city, and preferred car type. Each of these fields is essential for storing accurate customer information. For example, the customer ID serves as the unique identifier, while the preferred car type field captures the customer's choice of vehicles such as sedan, SUV, or compact. In design view, we added several common buttons to enhance the functionality of the form. These buttons include Save, Delete, Next, and Previous. The Save button allows staff to record a new entry or update changes to an existing record, while the Delete button removes the current record from the database. The Next and Previous buttons enable easy navigation through customer records, allowing staff to quickly find and review specific information without manually searching through the database. Each button was configured using the button tool, and clear labels were added to ensure that staff could easily understand and use the form. Now, let me demonstrate how this form works in Form View. To add a new record, I will enter the customer's details into the fields, select the preferred car type from the drop-down menu, and click Save. This action ensures that the new entry is saved into the customer's table. To delete a record, I navigate to the specific entry using the Next or Previous buttons and then click Delete. The record is immediately removed from the database and the data is updated accordingly. The second form is the rental data entry form, which is used to manage all rental transactions. This form captures details such as rental ID, customer ID, car model, rental start date, rental return date, rental fee, and payment method. Like the customer data entry form, this form includes drop-down menus for key fields, including car model and payment method. The drop-down for car model ensures that only valid models such as Viva, Azia, or Alza can be selected, while the drop-down for payment method allows staff to choose from options such as cash or online transfer. These drop-downs enhance accuracy and reduce errors during data entry. In design view, the rental data entry form also features the same set of buttons: Save, Delete, Next, and Previous. These buttons are configured to perform actions similar to those on the customer data entry form, ensuring consistency in functionality across both forms. The Save button records new transactions or updates existing ones, while the Delete button removes the specific rental records. The Next and Previous buttons allows for easy navigation through the database, making it simple to review or manage rental information. To demonstrate, I will switch to Form View. When adding a new rental transaction, I input the details, select the car model and payment method from the drop-down menus, and click Save. This saves the record in the rentals tables. If I need to delete a transaction, I navigate to it using the Next or Previous buttons and click Delete. The record is removed instantly, These features make the rental data entry form an efficient tool for managing rental transactions. Finally, we created a multi-page form to integrate customer and rental data into a single interface. This form includes a tab control with one tab dedicated to customer information and the other to rental data. On the first tab, fields from the customer's table are neatly arranged, allowing staff to view and manage customer details. Similarly, the second tab contains fields from the rental's table, providing easy access to rental transactions. Navigations and action buttons such as Save, Delete, Next, and Previous are placed outside the tabs to ensure they work across both sections. In design view, the tabs were customized to make the layout intuitive and visually clear. By organizing the data into separate tabs, this form allows staff to switch seamlessly between customer and rental information without needing to open multiple forms. In Form View, the multi-page form demonstrates its usability by enabling staff to navigate between tabs, view details, and perform actions with ease.
Alright, I will explain how we generated the report in Microsoft Access to provide valuable insight for Swift Ride Go car rental. Reports are essential for summarizing data in a structured format, enabling the organization to make informed decisions. We create 3 reports. The first one is the customer report, the rental report, and the multi-table report that combine customer and rental data. Let me guide you through the steps for each report and their significance. The customer report was designed to present a detailed summary of the customer information. To create this report, we use a report wizard from the Create tab in Access. The data source for this report is the customer table, which store field like customer ID, name, contact information, city, and preferred car type. After selecting all the necessary files, the wizard generates a basic report structure. To enhance the presentation, we switched to design view and added a group photo related to the car rental businesses using the Insert Image tool. This image was placed at the top of the report to create a professional and visually appealing layout. Additionally, we formatted the report by adjusting file field size and ensuring all information was clearly visible. Once formatting was complete, we saved it as customer report. The rental report focuses on summarizing rental transaction. We began by selecting the rental table as the data source in the report wizard. The field included rental ID, customer ID, car model, rental start date, rental return date, rental fee, and the last one is payment method. During the report creation process, we grouped the rental by rental start date to organize the data by time period, making it easier to analyze trend. And to add further value, we summarize the rental fee field by calculating the total fees within each group using the sum option in the wizard. This provides an immediate overview of revenue generated during specific periods. In design view, we refined the layout to ensure all fields were visible and add a title Swift Ride Go Rental Summary to emphasize the report's purpose. After finalizing the adjustment, the report was saved as a rental report. The multi-table report, also known as the customer rental report, combined data from the customer table and rental table to show all rental transactions made by each customer. To create this report, we first built a query named Customer Rental Query using Query Design. The query joined the customer table and rental table through the customer ID field, ensuring accurate connection between the data. We selected relevant fields such as customer ID, name, and contact information from the customer table, and rental ID, car model, rental start date, rental return date, and rental fee from the rental table. Using the query as the data sources, we opened the report wizard and included all fields in the report. During the wizard setup, we grouped the report by customer ID to display all rental made by a single customer together. This structure allowed the business to analyze customer activity comprehensively. In design view, we add also title and adjust the layout for clarity and included calculated field to show the total rental fees for each customer. After these refinements, the report was saved as a customer rental report. The database system for Swift Ride Go has resolved the key challenges, including inefficient record management, manual error, and data security risk. Using Microsoft Access, the system ensures accurate data storage, quick analysis through query, easy data entry with form, and actionable insights from report. This improves efficiency, reliability, and service quality, also positioning the business for growth. That's all from us. Thank you.